Now we come to the trigonometric ratio of 0 degree. Okay, trigonometric ratios of 0 degree. Now you see there is a trouble. If it is this and I make one of the angles 0 degree, then the hypotenuse falls on the same line, is it not? The hypotenuse falls on the same line. Earlier maybe when I was drawing 45 degree, it was something like this. But if I make 0 degree, then somehow this hypotenuse falls on this very line. And it is no longer a triangle. Now that's a trouble. We had defined everything when it was a triangle. Okay? So to understand that, what we do, we take it some angle and start making it 0 gradually. Do you get the point? I start making it 0 gradually. How? So it is something like this. Then what do? I kind of, okay, so earlier it was like this, now it is something like this. I again make it smaller, while earlier it was something like this, correct? And I kind of made this very, very, very small, while earlier it was something like this. As this angle, so this angle is gradually tending towards, we call it tending towards, it is moving towards 0, correct? It is moving towards 0. So what happens to the perpendicular? The perpendicular, which is the opposite side, that tends to, we actually call it like this, P tends to 0. Tends to 0. As you start moving towards 0, then this starts tending towards 0. While you can very well see the length of this starts becoming equal to the hypotenuse, starts becoming equal to the base. See, if perpendicular in your Pythagoras, if your perpendicular starts going to 0, obviously b square is equal to h square. Though it will never go actually down to 0, you should understand that. It will never go down to 0 actually, because if it goes down to 0, it no longer remains a triangle. Fine. But whatever is that tending value, whatever it tends to, that we use for 0 degree. Fine. So what happens? What happens is sine 0 degree is this perpendicular, which is 0 upon hypotenuse, so that is equal to 0. So what is cos x 0 degree? That becomes 1 by 0, which is infinity. What is cos 0? That is base upon hypotenuse, and base starts becoming equal to hypotenuse, or hypotenuse starts becoming equal to base, so that is equal to 1. So sec 0 degree is equal to 1. Tan 0 is perpendicular by base, perpendicular upon base, perpendicular is 0, so it is 0. And cot 0 is 1 by tan 0, correct? 1 by tan 0, which is equal to 1 by 0, which is equal to infinity or not defined. It becomes a very, very huge number. You understand what infinity is? See, I am dividing it by 0. Okay, let us say if x is 0.1, what is 1 upon x? 10. If it is 0.01, what is 1 upon x? 100. If it is 0.001, this is 1000. If it is 0.000001, then it is this. So you see what happens as my x starts going towards 0, though it has still not become 0, my 1 upon x, the reciprocal of that starts becoming a very big number, very big number. We get that point? We get that point? So what happens in the limit as it tends to 0? This becomes infinity. This becomes infinity. Okay? Fine. So these are the trigonometric ratios. That's why I am writing infinity. At times they write it as not defined also. Not defined. In fact, infinity is something that is not defined because it is greater than the greatest that you can ever imagine.